Hey everybody, today we are looking at Chapter 5, Section 3, which is medians and altitudes of triangles. First thing we need to know is what a median is. A median is a segment whose endpoints are a vertex of the triangle, which is right here at point C, and the midpoint of the opposite side, which is over here at point D. Okay, so its vertex to midpoint is going to be our medians. Our medians are concurrent, so again, that means that they meet in one point, and that one point is called the centroid. A little bit of a fun fact about the centroid is it is also called the center of gravity, because if you were to cut out a triangle out of cardstock or heavier weight paper, if you find the centroid of that, then if you put the triangle like on the tip of your pencil at the centroid, it will be balanced. So it's kind of cool. Also, the centroid, like your incenter, is always going to be inside the triangle. All right, our theorem for our centroid is that the distance from the vertex of the triangle to the centroid is 2/3 of the length of the entire median. So if this is 2/3, let me write in a different color, of the length, then that makes this 1/3 of the length. Okay. And one thing that I kind of want to focus on here is that if I know this length and this length, this one is going to be half of this one. Because when we look at the distance, BP being 2/3, well, if we take 2/3 and we divide it by 2, we get 1/3. Okay, so this piece from the centroid to the midpoint is going to be half the length of the centroid to, or excuse me, yeah, the centroid to the vertex. Okay, but when we compare it to the entire median, it's 1/3 of the whole median, and this is 2/3 of the whole median. So I know right now that might be a little bit confusing. We're going to do some examples with it here in just a sec. So let's take a look. Here, I am told that SP is 16. Okay? And I want to know what SM is, which is the whole length of the whole median. Okay? I know that these are medians because I know that these are all midpoints because they are congruent here. So I'm going vertex to a midpoint, so this is the whole median. So two ways that I can do this. I know that SP is 2/3 of SM. All right, so SP is 16. And then I can multiply both sides by 3/2, which is the reciprocal. All right, and 16 divided by 2 is 8. 8 times 3 is 24. The other, not 2M, SM. Okay, the other way that I can do this is easier than this. Okay, I realize that if this is 16, this is my 2/3 piece because it runs from my vertex to the centroid. Okay, that means that this here is my 1/3 piece. Remember that this piece is going to be half of this piece. So I'm going to take 16 divided by 2, and I'm going to get 8. 8 plus 16 is 24. Okay, so we can do it either way. But I feel like just going, oh, hey, this divided by 2, add them together, that's probably going to be a little bit easier for you. All right, so then let's take a look at the next one. We're told that LP is 9, so LP right here is 9. And I want to find the whole thing, which is LT. So again, I know that LP is my 1/3 piece. So if I do this the long way, I know that LP is 1/3 of LT, which is the whole median. Okay, so LP is 9, is 1/3 of LT. I can multiply here both sides by 3. 27 is LT. All right, so, or I can look at it, okay, I know that this is 1/3, so this is 2/3. Well, if this is 1/3, it's half of this one. So I know that this is 9 times 2, which is 18. Add them together, I get 27. All right. Then the last one that we're going to look at is I'm told RN is 33, and I want to know PN. So remember that again, I know that PN is a third of the whole thing because it goes from the centroid to the midpoint. So this is going to be a third of Rn. So Pn is a third of 33. So Pn is 11. Okay, and then that would make this here 22 because it would be doubled. Added together, we get 33. Or in your head, you can just go, okay, if I'm looking for the 1/3 piece, I'm taking that 33 and I'm dividing it by 3. Okay, so if you have questions on that, go ahead and write them down now. All right, next thing that we're looking for here is we are looking for basically where the centroid is. So we want to show, we're drawing a diagram for a piece of a mobile. So the mobiles are the things that like half the time hang above like the little baby cribs. So we want it to be balanced and we want that triangle to be balanced. Well, remember that your center of gravity is the centroid. So we want to find the medians, which means that we're looking for the midpoint of each side. All right. So that means we're going to be looking for some midpoints and doing some midpoint formulas. So if I find the midpoint of QR, all right, remember that our midpoint formula is that we are adding our x's dividing by 2. So 0 plus 6 divided by 2. Adding our y's dividing by 2. So 8 plus 4 divided by 2. So this midpoint here is going to be 6 over 2, which is 3. 8 plus 4 is 12 over 2, which is 6. So 3, 6 is right here. All right, then we can look at the midpoint for QP. And we have adding our x's again, we're going to add 0 and 3 divided by 2. And then we have 8 and 0. 8 plus 0 divided by 2. All right, this is going to give us 3 halves. And 8 divided by 2 is 4. So we're going to go over 1.5 up 4. So this is the other one. And then we have one more midpoint of PR. Add our x's again. So 6 plus 3 divide by 2. And then add our y's. 4 plus 0 divide by 2. So this is going to give us 6 plus 3 is 9. So that's 9 halves, which is 4.5. And 4 divided by 2 is 2. So we're going to over 4.5 up 2. Here's our other midpoint. So now to find our centroid, all we're going to do is go from the vertex to the opposite side. Okay, to that midpoint. So from the vertex to the midpoint. From the vertex to the midpoint. Oh, that got a little crooked. And then we just look to see where they intersect. So you should be able to notice that we are intersecting right here at 3, 4. So our centroid is at the point 3, 4. Okay? So this is our answer. So again, finding the midpoint of each side and then drawing the segment that connects the vertex and the midpoint. All right, questions about that, go ahead and write it down.